Good morning and good evening, good afternoon, wherever you may be, and welcome to the Spring Webinar Program. I am Peter Humphrey, do developer marketing for Spring and Cloud Foundry. I work at Pivotal, and I am delighted to introduce to you today, if you haven't heard from him before, Michael Plewd, who's going to talk about domain-driven design. Michael, with no further ado, I'm really excited to have you back, frequent Spring Run speaker. So welcome back, and yeah, let's dive right into it. Curious to hear about what you have for us today.
Okay, thank you very much, Peter, for the kind introduction, and welcome everybody to joining me on this webinar on a topic that I would say is getting quite a hype recently. Again, because domain-driven design isn't something very new. It originated back in, I think it was 2003, with the excellent book by Eric Evans, and with the rising of the idea of self-contained systems or microservices, domain-driven design really had another push in the community in my eyes. Today, I'm going to talk about strategic design, which is, I would say, one of the major chapters in the book that has a very, very high relevance to the whole idea and the concept of microservices, for instance. And I'm going to cut this webinar today basically in, let's say, two parts. In the first part, I will introduce to you the idea of strategic design, what strategic design is all about. We're going to talk about bounded context. We're going to talk about context maps and the mapping patterns in the context map. And after that, we're going to take a look especially at the context mapping part over an example landscape, application landscape, that has been written with Spring Boot. And it has to do something about this puck. Who is a very, let's say, business-driven puck. And don't be afraid, I'm not going to show you another pet store or another pet shop with that example. But let's start with introducing myself. My name is Michael Plewd. I work for a company called InnoQ. I'm a principal consultant, and I usually do a lot of stuff around Spring. I did a couple of talks at the Spring One conference, have already done a webinar for the Pivotal folks surrounding Spring. And you can follow me on Twitter. My handle is @bitboss, and I will also share links to the code and the slides right after the talk on my Twitter account. But the first thing is you can also check out all the code for the application landscape I'm going to show on GitHub. But don't be shocked. It's not a best practice code. And why that is the case, please read the README to that very carefully. It is because I want to demonstrate a couple of the patterns that you can see when you draw a context map of an application landscape. Before getting into the contents, I really have to say that I didn't invent anything of that. I'm a huge fan of the ideas that Eric Evans and also Vaughan Vernon and a lot of other people in the DDD community have written down. And if you haven't bought the books yet, I can highly recommend to you to buy Eric Evans' book on domain-driven design, Vaughan Vernon's book, Domain-Driven Design Distilled or Implementing Domain-Driven Design. These are absolutely great books, and let's be sure they will last a very long time in your bookshelf. Eric's book is now over, I think, 12 or 13 years old already, and we're still talking about this topic. Basically, the part of domain-driven design. Domain-driven design isn't basically only about, let's say, the internal building blocks. That we have been talking a lot about, let's say, in the early half of the year 2000 and or also the mid-half of the year 2000. In the internal building blocks, there were a lot of now really well-known patterns like the entity, the value object, and the repository. So if you, for instance, take a look at the Spring Data stuff, you will find an add repository annotation, and you will also see a couple of a lot of the ideas from the repository pattern from domain-driven design implemented directly into Spring Data. And domain-driven design also consists of a part called strategic design. I won't dwell into strategic design right now because this is the major part of the presentation of this webinar I'm going to deliver right now. Another parts of the book were on large-scale structure. So basically, how do you grow with domain-driven design? How do you go ahead and grow applications? And also, very important here is the part of the distillation. How do I go ahead and distill stuff from a grown application into some smaller chunks? And when we take a look, especially at the part of strategic design and the distillation part, we will see that a lot of these ideas that have been sketched out in the early 2000s now match very, very good on the idea surrounding cloud-native applications, 12-factor applications, and especially on the idea surrounding microservices and self-contained systems. And in my eyes, and that is something I actually wonder quite a bit about, is that a lot of the people in the microservices community discuss, let's say, structuring microservices along bounded context. That is very true, and this is a really, in my eyes, a major driver for really independently and quickly deployable microservices. But let's be honest, among us who are now in this webinar, not everybody is writing greenfield applications right now. I mean, if I take a look at a lot of my customers that I'm consulting, they have a very strong set of grown applications where they have invested millions and millions of euros or dollars in them. And you can't just go ahead to a customer and say, huh, go ahead and shut down that application. Let's rewrite it from scratch. I mean, that would be a very career-limiting move to do. So we have to be a little bit smarter, and we have to see how we can eventually go ahead and take these applications apart, analyze the applications, analyze the landscapes, and identify parts that we can isolate and squeeze out towards, for instance, microservices. And this is exactly where, especially the context mapping part of strategic design really helps us. And strategic design consists of, I would say, two major things. The main driver is the bounded context. And this is, I would say, the central part to strategic design. But there is also the context map, which is a means to describe and to sketch out an application landscape. And along that context map, you will see various, I don't want to call them integration patterns, but I would like to say, call them interaction models between systems and teams. And let's go ahead and dig into this part of strategic design. So let's first off all go ahead and take a look at the bounded context. The bounded context is basically something that says every sophisticated business domain consists of a bunch of bounded contexts. So, for instance, if you have a mortgage loan application, you can easily identify a couple of parts in these applications. For instance, a part where you apply for a mortgage loan, a part where the bank is going to score your mortgage loan application, where they say, yeah, we're giving the loan to Michael for instance, let's have him buy a house, depending on a couple of criteria. Then there is a part where we have, for instance, a credit decision where the management of the bank goes ahead and says, yes, let's go for a loan, or nah, let's rather not give a loan to the person applying for it. And finally, we have a repayment. So these are bounded contexts. And the bounded context contains models. I mean, the model is something that is being described in the internal building blocks of domain-driven design. So there you have your entities, your value objects, your aggregates, your repositories, your services, your factories, and they may also issue domain events for it. And the most important part about the understanding of the construct of the bounded context is that it is the boundary for the meaning of a given model. And that is something that goes a little bit against the grain of, for instance, ideas like service-oriented architectures or stuff that we've been doing in the last couple of years, where we tried to, let's say, centralize meanings of models. I'm from Germany, and in Germany there was a huge trend quite a few years ago called das Unternehmensdatenmodell, the enterprise company-wide data model, where organizations tried to centralize the meanings of given models. And, well, let's be fair, it failed. I don't know any company at all that really succeeded with such a centralized definition of a meaning of a model. And basically, if we take a look what we've been doing in our industry for the last couple of years, we've been fighting back and forth with centralized models, or don't we go ahead and go for decentralized models. Nowadays, if we take a look at the ideas surrounding microservices, we will obviously see a strong tendency for a strong decentralization, because we want independence. We want to be able to deploy components independently. We want to be able to deploy one Spring Boot application very often during a day, but we don't want to affect other teams with that. And in order to give you a better glimpse or a better grip on the meaning of a bounded context, let's take a look at an example. I guess a lot of folks of you know the really awesome Spring One conference, which is going to take place in San Francisco this year, or, for instance, for the Europeans, the absolutely amazing Spring I/O conference, which is a community-driven conference surrounding everything in Spring, which takes place in Barcelona. And these conferences obviously need some software to manage themselves. And I have identified a very simple, let's say, bounded context model for these conferences. So we have some reservations, we have some event management context, and then you know it from every conference, everybody's running around with a badge around their neck, and this stuff needs to be printed and done as well. And now we have a customer coming in to the conference that wants to attend the Spring One conference. And I mean, the customer is, let's say I want to go to one of the conference. That's me, I'm standing there. But let's take a look at how we see the customer in the reservations context. In the reservations context, I would say we have a rather natural modeling view on the customer. So they have a name, there's some payment details, there's an address, the customer works at a specific company. I mean, this is a model that is, I would say, very true to a lot of CRM or whatever applications. The interesting thing is how we see the, let's please put that in quotes, the customer in the context of the event management. there, basically, we don't see the customer the way she or he stands in front of us. Basically, the customer can be seen as a lunch preference. So I, as a visitor of a conference, get reduced to a crappy lunch preference. I'm a vegetarian, I'm a meat eater, I'm a vegan, or whatever. So we don't see, in this context, a customer. We see a meat eater. We see a vegetarian. We see a vegan, or somebody who wants kosher food, or whatever. So it's basically, you don't see the customer in the event management. It's basically a lunch preference. And we also want to see, for instance, in this case, who wants to attend which sessions. For instance, if Jürgen Höller is giving a talk at the Spring One conference as one of the original founders of the Spring Framework, he's obviously getting a lot of attention. A lot of people want to go there. On the other hand, if I do one of my talks, maybe people say, no, he's not a part of the Spring team. I'm going to skip out on Michael. There's just a few registrations for that. So basically a customer isn't a customer. It's an amount of session registrations, of interest for giving sessions, for giving talks, so that the organizer can scale the rooms. Let's put Jürgen into the big room, and let's put Michael into a small, tiny room for whatever, 20 people or something. Fair enough. And then we have an interesting case with the badges. Basically, in the badges, we don't see the customer as well. The central model in the badges is the badge. Basically, me as a customer, I get reduced to a lunch preference, and finally I get reduced to a printed piece of paper. So where I have my name and a job description and, for instance, my Twitter handle at BitBoss. And so this takes into account that we can basically work with some sort of a decentralized data, and that is very important, decentralized behavior as well. Let me give you another example. This was, let's say, a very data-centric example. Another example is, take a look at a car. I'm not a very big cars guy, personally. I want to get into a car, turn it on, and push the pedal to the metal, as you say in English, I guess. And I want to drive from A to B. That's all I care about cars. And on the other hand, I have my service center, and there's people working in the service center. And take a look at how they see the car. If I model a car for the context, Michael Plöd, usual user, nothing special, whatever, take a look how you would model the car of the car. Would you go ahead and say car get engine dot start? Probably not. You would invoke a method car dot start in that context, and the car knows how to start itself, because there's a couple of other systems, the GPS subsystem, navigation, infotainment, and whatever you have, ABS systems, ESP, and whatnot in the cars. So the car knows, okay, I need to start the engine, I need to start the light system, I need to start the GPS subsystem, and whatever. The car knows that. It's hidden from me. And a quick hint for you guys, if you want to monitor the quality, there's basically a nice law called Law of Demeter out there that helps you to identify such cases where you eventually have a model that doesn't fit really nicely to the context you're in. So it would go too far for the given time frame of that presentation to dig deep into the Law of Demeter. But eventually, if you're interested in that, Google it, you'll find a lot of examples. Now, going back to the context with the car, let's go to the service center. The service center sees the technical person in the service center who's repairing your car sees it totally differently. They may start the engine in an isolated way. They may start the infotainment system without the rest of the system in order to be able to debug the car, to repair it, and whatever. So you have a total different view on the car. And you can go even further if you go to the factory and you take a look at how they see the car. This is also a total different view of a car. Now, let's pick up this example again with the reservation center conference. So each bounded context has its own model and its own view of a certain customer. So we go from a very natural modeling of the customer to a lunch preference to a piece of paper, basically. And this is a major enabler for really independent microservices. So if you really want to be able to deploy independently, to give teams an empowerment of going away from a project thinking towards a product thinking, this is a big, big enabler. Because let's say the badges team in my example, one team and they write one microservice for the badges. They don't necessarily have to care about what's happening in the reservations, for instance. And we have a choice by that of you. If you take a look at the name of the customer, we have the name in the reservations context and the badges. So eventually we want shared data or we want to avoid shared data. But the good thing about that is we can make an educated decision on that. Basically in the centralized IT world, let's say the old school enterprise IT world, you wanted, of course, the answer would have been, yes, of course we want to share data. It would be a total catastrophe not having shared data. Here, in this point of view, you can differ. You can go away and say, let's go separate ways, for instance. Now talking about separate ways, we get to the next part, which is the context map. The context map is basically a, let's say, a view on the interaction between bounded contexts, because bounded contexts by themselves don't deliver a decent overview of the system, because you don't know who is interacting with whom and how do they interact and whatnot. And by introducing the context map, we go ahead and describe the context between models and context. And it is a very good starting point for future transformations. Let me be very clear here. In my eyes, the context map is one of the really, really shiny big gems in domain-driven design. Why? Because if you take a look at how a lot of, let's say, enterprise architects sketch out or model or draw their systems, you will find out that most of these diagrams focus on, let's say, delivery relationships or customer-supplier relationships. System A is calling service X of system B. Let's say, mortgage application system is calling the scoring methods of the scoring system or something like that. And I mean, this is a very important way to sketch out a system, but in my eyes it falls a little bit short in one very interesting thing, and that is the fact that these sorts of diagrams don't show you what is happening with the models inside the consuming system. So for instance, if you ask a credit agency for a scoring of a given customer, you obviously get a model back from them, which is the scoring result. Now, what is being done with the scoring result? Do you store it in your own database the way it is? Do you transform it or whatever? This isn't being explained in, I would say, the typical enterprise architecture diagrams that we usually see. And another thing that's also not being taken care of is the way how certain teams interact with each other. Let's say, I'm very honest, there is no judgment on the political stance and behavior of a given team in a organization. And this is exactly what the context map displays. It doesn't just display call stacks or call relationships. No, it displays also how this relationship is being lived out in the corporation. And in my eyes, the context map goes hand in hand with Conway's law. And let's dig a little bit into it. The context map usually starts with an existing system, with existing applications. So, I've rarely seen people drawing a context map in a greenfield approach. You usually have a system or a couple of systems that interact with each other, and you go ahead and analyze them, and then you draw a context map. And there are a couple of patterns being defined in Eric's and Vaughan's books, and it's basically 7 of them. And please don't be mistaken by the name pattern when I say that. Some of these things, for instance, the shared kernel, to which I'll get to you in a minute, is something that a lot of you, when you see it and when I explain it to you, would feel pretty awkward with implementing in a greenfield approach. But it is basically stuff that happens in real-world systems, and that I see quite a bit in customer situations that I'm in. So it's not a, let's say, upfront design kind of thing. It's more an analysis method, how you can take a look at given systems and how you rate relationships between contexts. Now let's dig into all these patterns and start with the shared kernel. The shared kernel says that 2 teams or 2 bounded contexts share a subset of the domain model, including the code and eventually the database. That is something, for instance, if we take a technical look, if we use, let's say, some old school binary protocols such as Hashian or RMI or old school EJB remoting, you usually have your, let's say, client jar files or client class files somewhere lying around, and each system relies on them on a binary level. And eventually there's behavior in there, there's data in there, and this is a very tightly shared kernel between the two. So obviously you can't change anything in one system without changing the other system as well. But please be aware with the shared kernel, it's not just about, let's say, binary protocols. Just imagine 2 systems or 2 teams writing 2 pieces of software, and they don't call each other a lot. There's not a very tight interaction between them, but they are both running on the same database, accessing the same tables in the same schema, and so on and so forth. And even if you go for a modern concept such as domain events, and if you have domain events that carry a lot of stuff with them and a lot of, well, let's say, a very big model in them, I think there is also a chance that you couple the 2 applications on events so closely that you can basically say there is a shared kernel between the 2. Now, in my eyes, you need to differentiate a bit. If this is very bad or if it can be tolerated. Let's be honest. I mean, IT is always a collection of trade-off decisions. There is never a perfect world. No matter where you look, you always have trade-off decisions. Now, if the 2 teams, their success relies heavily on each other, so basically both succeed, and it's all good, then you can say, maybe this can be tolerated in some sort of way. But if that is not the case, the shared kernel can be quite a toxic element. Another thing is, let's say one team provides a service for another team. And the other team is calling the service, and we have a customer-supplier relationship between the two teams. In this case, the downstream team, which is the consuming team, is playing a very dominant role in the organization or in this, let's say, this interaction between the two teams. So basically, they can have a veto right. And that is something that you usually do not see in the code. Now, if you do an analysis of these systems, maybe you want to ask the question, hey, how did the last interface change or the last model change go down with the other team? And when they say, oh, don't mention that, the boss of the other team went crazy, he went nuts, escalated it throughout the complete organization, and we had to pull it back, there is a strong indication that you may eventually have a customer-supplier relationship between the teams. Same scenario, but totally different behavior is the conformist. In this case, the downstream team, which is the consuming team, basically conforms to the model of the upstream team. There is basically no big translation of the models and also no vetoing. So they have a very, let's say, defensive role in the organization. They take whatever they want. This can be due to, let's say, political power in organizations. That can be the case. But it can also be the case when you just go ahead and take a model and and you copy the model. For instance, I once ran personally into a very bad conformist situation. I'm running a online music magazine for heavy rock music, and let's be honest, displaying tour dates is very thrilling for a team that is providing such a magazine. So we looked into websites and whatever that provide us tour dates, and there was one site that was really fantastic. They had a good API, a good offering for systems writing code on top of the API, and we went with them, and we totally conformed to them in our internal model. So basically, the database was modeled after them, the UI layer was modeled after them. It was, well, in the first run, it was great, but then suddenly they stopped the service. I mean, I couldn't pick up the phone and complain to them because they would have just shut my call down, but we're stuck basically without tour dates, but being a total conformist to another external model. And then we looked into different other offerings, and we found that one, and we had to take a decision. Okay, do we rewrite our whole code? Do we rewrite the whole system? Because we were so much conforming to the other model. But basically, we liked the model. It modeled tour dates and festival tours and whatever really well. So we decided, no, let's define that as our new internal model and go with an anti-corruption layer. Basically, an anti-corruption layer is a layer or even a microservice that isolates a client's model from another system's model by translation. And you can, in my eyes, you can see an anti-corruption layer as, let's say, a simple mapping layer in a piece of code, but you could also go ahead and really, for instance, if you have a lot of legacy applications in your organization, you can see that as a gateway to a more dynamic part of the IT in your organization. And let's say I call them anti-corruption microservices or something like that. But for instance, are able to consume domain events and whatever. And something that we actually want to do with our microservice idea and with cloud-native applications or self-contained systems is that we don't see a lot of connection between the bounded context of a system. So every team can find their own solution to their domain. So there's basically one case where the teams really don't have any contact point to each other, fair enough. But I would say that you also have to see how you go along with separate ways. For instance, if you have a very domain event-based system, you may eventually go ahead and rate that as separate ways as well. I'll get to that later on. The last two are, let's say, important, yes, but not as central as the other one. The open host service basically says if one context delivers functionality to other systems through a exposing through an interface or something. So if you have a REST interface, a web service interface or something, that can be rated as an open host service. This is usually a model for the upstream systems, so the providing systems providing the functionality. And the published language is something that you usually have on your open host service. So with every model that you give out, you publish a certain part of the language to other systems, to other contexts. And please don't overdo the published language kind of thing. I already see a couple of people who are still fans of the centralized company-wide data model, and they say, oh, great idea. Let's do a centralized published language. No, don't do that. You will be missing the point of it. And now let's say, why is that so interesting? Let's take a look at this system here. So for instance, we have a, let's say, a mortgage or a credit application. And we have the credit application is calling a CRM system where we have a customer. We have a scoring system which is talking to a credit agency. We also have a credit decision context. And that is something that a lot of you have already drawn out or sketched out in UML diagrams and whatever, or context diagrams, however you want to see. But here, so far, we only see call stacks here. And now let's add the idea of context mapping to that picture. Now, first of all, we classify who's the upstream, who's the downstream system. Downstream is consuming system. Upstream is the providing system. Why is it called like that? Take a look at a river. I live in Nuremberg, Bavaria, and next to Nuremberg is a city called Fürth. And, well, for instance, if you see it in the US or wherever, two neighboring cities always have a sort of a rivalry between them. And between Nuremberg and Fürth, there is a river passing, which is the Pegnitz. And it's a tiny river, not a big thing like the Danube or whatever, doesn't matter. And the river is flowing from Nuremberg to Fürth. So Nuremberg is upstream, Fürth is downstream. So if Nuremberg is putting a lot of waste into that river, it flows down to Fürth. And the Nurembergers would say where it belongs. But joke aside, basically Fürth is downstream. It can get the waste from the upstream. And the same is with models. If you have a crappy model in the upstream system, it can propagate down to the downstream system and make that model crap as well. Now, let's add some examples on the context map. For instance, the credit agency, the credit decision, and the CRM are providing open host services. So there is a, let's say, they provide some interfaces, for instance, through REST calls or web services or whatever. Now the interesting part begins. Between scoring and the credit application, we have a shared kernel. These are very old school applications. They're still communicating with each other through RMI. So there is a strong shared kernel. Now, between the credit agency and scoring, we have a conformist on the scoring side. So the scoring bounded context is conforming a lot to the model of the credit agency, which it is consuming. And the credit application has a very bossy boss, and he's always fighting with the credit decision team, making this a customer-supplier relationship. Whereas we have an anti-corruption layer between the CRM system and the credit application. The interesting part here we see is the way from the credit agency to scoring to the credit application. Please take a close look here. Scoring is conforming to the credit agency. Credit application has a shared kernel with scoring. So there is a chance or a big risk that basically parts of the model of the credit agency are flowing down into the credit application. So if you want to switch the credit agency, for instance, in Germany, we have a couple of these. One is the Schufa, the other one is InfoScore. If you want to switch from Schufa to InfoScore, for instance, your first assumption on the enterprise model would be, no big deal. Let's just change the code in the scoring. And mid into the project, somebody realizes, excuse me, damn, we're in trouble. We also have to adjust the credit application. And these are very valuable insights that you gain. And now, so far for the theory, let's take a look into the practice. I promised it's not going to be a pet shop. This puck owns a bank, and he's giving out loans. It's called Big Puck Loans. This is an application that is running on Cloud Foundry. So basically, this is an application which I'm hosting right now on the public Cloud Foundry, and there's a credit agency, credit application, customer microservice, some customer contact kind of thing, and a scoring engine. And if we click through this, we can basically apply for a loan, let's say 12 months, 1,200 euros, purpose, a new puck, and we have an income, let's say the person earns 4,000 euros, no rental income, but they have to pay 1,500 for rent and 300 for loan repayment, and let's say another 400 for cost of living. And after that, we catch up with some customer details. First name is Michael, Flöd, Kreuz, Straße 11, 8331 München, which is our InnoQ office in Munich. So if you want to come by and say hi, do that. And then we perform a scoring of this. And this is basically the process that we are running through now. So obviously the puck says, yes, I financed the purchase of new pucks. Very good, go ahead. All power to you. And let's take a look at the code now and imagine a context map. Basically, what we see here is we have a couple of Spring Boot applications. The credit agency, the credit application, the customer contact, scoring, and scoring shared kernel. This is not a Spring Boot best practice application. Please be aware of that. I have added, and you will see that, a couple of nasty things in there. The first thing is I put a lot of logic into my controller because I want to make it easy for you to follow it up in your code. Obviously, for a production system, I would handle these kinds of things differently. I've also switched out all the Spring Cloud goodness, so no Eureka, Hystrix, or whatever. I really want to focus on the DDD part here. Now, the first step is, after the first page, we go ahead and basically save the credit application to the repository of the credit application here. So going back there, basically, what I have here is very similar. Let's make that a bit bigger. Oops, that's too big. Just the size. Yeah, that's better. So basically, we stay in there in this credit application thing. Now, in the second step, we go ahead and interact with some customer clients. So we caught some input for the customer, and we are now directing this one to the customer system here. Now, the customer client in the credit application, take a look at that. in the integration part. Looks like that. And what we see here is we have a public web service model from the WSDL, from the customer. And we are mapping our own customer to the client, to the upstream customer. In this case, it's a one-to-one mapping. So either we could say, we have a conformist here, or we have an anti-corruption layer. Since it is isolated here, I would rate that as an anti-corruption layer between the customer system and the credit application. And the customer system is also providing an open host service because it has a web service interface. Now, after that, we go to the next part, and we jump over to the scoring thing. So we interact with our own code, and we go ahead and perform some scoring on this thing. So there is an interface called scoring input, and the scoring service performs the scoring. Now, what is this scoring service about? Now, where is that located? We see the scoring service is located in the scoring shared kernel. Strange. Also, the scoring input class, some agency color and whatnot. Let's take a look at the configuration. There is an integration on a binary level between the credit application and the scoring application because we're communicating with each other through Hashian. Hashian, for those of you who don't know it, is an HTTP-based binary protocol, which is also supported by our beloved Spring framework. So you also have an integration into Hashian for Spring applications. Actually, for a binary protocol, it's pretty high performant. I would prepare it at any time over RMI and stuff. But what we have between the scoring and the credit application is a shared kernel between the two. And as we can see, there is another jump to the credit agency over there. Now let's jump right into the scoring application and go ahead and take a look at the scoring service. What's happening right there is we perform a scoring. It's a REST call, obviously, HTTP entity, Spring's REST template, and so on and so forth. And we get an agency result. The agency result is something we get from the response body, and it is something that we directly, or more or less, return directly to the result over through the shared kernel to the credit application here. I mean, there's a couple of rules. So, for instance, the PAG says if the reason for the loan contains the word PAG, it's a big bonus. Otherwise, you'll be screwed by him. But the interesting thing is here. Obviously, we are absolutely conforming in this service to the model of the credit agency. So we have a conformist here. And in this example, what we see here, please take a close look to the agency result in the credit application controller down there. We pass the scoring result to I, and we see the agency result right in the UI. So basically, if you switch the credit agency, they have a different model for their results and whatever, you will, I would say, run into big trouble because you have to adjust the credit application as well. Now, you may have wondered, what is this customer contact all about? We haven't talked about that yet. So far, we have addressed this way. We have the customer, the credit application, the scoring, the credit agency, and so on. Now, the customer contact comes into play here. Let's take a look at the customer application, for instance. After saving a customer we publish a domain event, a customer-created event, and we send it through Redis, through the Redis PubSub feature, which is also supported by Spring Data for Redis, for instance. Why did I use Redis and didn't use RabbitMQ? I say Redis is very easy to install. A lot of developers have it already running on their machines, and I wanted to make it very easy for you folks to try out these examples here. So that's the reason for Redis and not for using RabbitMQ or something like that. And in the customer context, what we have here is a part where we go ahead and we have a receiver for the customer-created event. And what we do here, we have our own customer-created event in the customer context thing, and it is able to convert a created customer to an address. And we're going to save that address to our own repository. So here we are working with eventually consistency and with a very decentralized approach to seeing models. On the one context, it's a customer. In the other context, it's basically an address. And in the end, at the credit application controllers level, we're sending out, for instance, a credit application approved event. And this event is being consumed by the credit application approved event receiver. And what we do is we go ahead and look for an address, in this case, and send it a fake letter, which is basically ending up in the log file here. So I'm not going to print out a letter or whatever. So this is something where a few teams might discuss that can be some sort of a separate waste, because there is a very loose coupling between, for instance, the customer contact, or the credit application and the customer contact system. I would say make a decision in your team how you want to rate that. I would say rating that as a sort of a separate waste is fair enough. Is it academically 100% correct? I wouldn't say that, but I think it is a very high degree of loose coupling that we have here. Now, that's it with the application. I suggest I'll share all the slides online. You can also check out the project on GitHub. And now my part here is over. You can still follow me on Twitter @bitboss. And if you're interested in DTD trainings or consulting, also with a focus on everything around Spring, you can contact me. And I would like to hand over to our awesome host, Peter, who also wants to share a couple of things with you.
Yeah, so real quick, just to finish off before we do some question and answer, if you could go to the last slide, Michael. Had a couple things.
I'll have to forward through the whole thing.
Oh, gotcha. Okay, while you're doing that.
Yeah, but just go ahead and ask some questions that you've collected from the audience.
Yeah, no problem, no problem. So real quick, folks, the replay will show up on the Pivotal website as well as the Spring YouTube channel. And so there should be an announcement showing on your screen right now that has links to both the where we post the replays on the Pivotal website, and as well as a shortcut to the Spring YouTube channel, and then all you need to do is look for the webinars playlist. So generally with the system we're using these days, the webinars will go right to the Pivotal website same day, the replays, and then it'll just take us a day or two to get it up on the YouTube channel. The nice thing about the Pivotal website is that there is a whole bunch of other Spring-related content that is not on Spring.io. So if you're looking for more content on Spring and a potentially wider perspective, there's a whole bunch of other stuff on the Pivotal website that is exclusive and isn't on the Spring website. So I highly recommend you check that out. A lot of it's sort of Spring Boot related or running Spring on the cloud and that sort of thing. Also, we would love to have you come back and join us on April 13th. Nicholas Frankel from Hybris, frequent Spring 1 presenter and Spring enthusiast, among other things. He's going to be doing a sort of Josh Long style talk about how Spring Boot works under the hood. So if you are thinking about doing microservices and applying some of these domain-driven concepts that Michael has been talking about today, and using Spring Cloud and Spring Boot, you'll probably want to know at some point how to go past the intelligent defaults and maybe do that sort of next level of debugging. So highly recommend you check that out and register. It sounds like also we've had some firewall issues today that people that can't get past, that can't allow RMTP protocol, we're having trouble with the webinar, so something to keep in mind. Last thing is, for folks that are looking for training and certification, obviously it sounds like InnoQ is offering some very specific courses around domain-driven, strategic domain-driven design and other things that I think are fantastic. If you're looking for more product-oriented training, that is something you can also get from Pivotal. It comes in a number of flavors, various instructor-led, live online and e-learning. And you can see there a little bit about what we're offering in terms of just sort of core Spring, certification track, the enterprise integration, and kind of using Spring integration and those sorts of things, as well as eventually getting to things like Spring Cloud and for microservice product training. So those are all available on the website. If you go to the Pivotal website and look for education, training certification, you can find that. There's also links to it on the Spring website in the footer. So with that, thanks for listening. Let's get into a couple of the questions. Had a bunch of good ones. I'm going to actually start with the longest question, seeing as we don't have too much time. Michael, one of the attendees asked, what is the right level of granularity when defining and decomposing bounded contexts? In the online shopping experience, is commerce or purchase product a good boundary definition for a bounded context? Or is decomposing it to like shop, browsing catalog, cart management, order creation, payment, order fulfillment, all as separate bounded contexts unto themselves? Like how fine-grained, do you advise people to look at doing this?
Yeah, that is indeed a really great question, and thanks for bringing that up, because this is a question that, let's say, a lot of my clients are discussing a lot. In my eyes, there is no perfect recipe for that. But let me come up with a couple of questions you should ask yourself when modeling it. If you have a context that can't be managed by one team alone, if it's just too big that you need 2, 3, or 4 teams, I would go ahead and split it up. That's the first rule. I would always say one context, one team. That's the first thing that I would bring to the table regarding that. The next is I would go into a discussion with my domain experts on that. I would discuss with my business people how they see their business, where they see relations between contexts, where they say, okay, this is extremely similar. There is a very high degree of cohesion between among the business rules, or there isn't a high degree of cohesion between the rules. If you don't have a high degree on cohesion here, I would split it up. So given the example that that has been written here, I would tend to browsing catalog, cart management, order creation, payment, order fulfillment, and so on. If you look at a lot of e-commerce applications, you will realize that these are by themselves actually already quite big contexts. And I wouldn't go extremely finely granular on that. I like there is a concept called a self-contained system, which in my eyes fits absolutely perfect on the view on a microservice you can write with Spring Boot, for instance. And there is a website called scsarchitecture.org, and I would highly recommend you to take a look here in order to get a little bit of input on how to model these self-contained systems and the context.
Cool. Yeah, I've seen you guys tweeting about that. I've been meaning to read that myself and make sure I get a handle on what you were talking about there. Cool. I think that also kind of answers the second part of the question is that gentleman had about how bounded context map to domain ownership, like the sort of people and delivery, you know, where you were talking about the. So yeah, there's a bunch of other questions, so I'm going to try to speed up a little bit.
Let me add one more thing to that. Domain ownership is for one context, and I always say DevOps is one thing, but it's absolutely perfect if you can also have a domain person in your team as well.
That's a good point.
That would be perfect.
Yeah, another aspect to a balanced team there, along with product management and QA and the developer. Yep, absolutely. That's a great idea. So just folks, the system is going to cut us off at 4 minutes after the hour, so that's literally all the time we have for questions. So it's not that we don't want to answer them. In fact, what we'd like to do is if you ask a question and we don't get to it, we're going to publish Michael's answers to those questions as attachments to the webinar replay on the Pivotal website. So again, go get that link that's displaying in the announcement right now, content.pivotal.io/webinars. And then if your question did not get answered, we will type out an answer to that and put it into the chat, put it into the replay as an attachment. So with that, I think there's one other question that I think is really good, that it kind of relates to what we were just talking about. A gentleman asks, does it mean if services share the database and code, are they really not that independent? Should a shared kernel be used carefully with microservices for that reason? And are there any good rules of thumb when to use a shared kernel? I really like that question. That one's great.
Yeah, great question. Absolutely great. I would say in the moment that services share the database and code, they are getting more tightly coupled to each other. That's the first step to a tighter coupling, and if you do that, you will sooner or later end up in discussions, oh, we can't set service A live without updating service B. And the only reason I could, for instance, live with that is if these teams, their success really depends on each other. Okay. So one more question, 1 minute. Peter, be quick.
Literally, I think we have like 45 seconds left. I think we should I think we need to leave it at that.
Okay.
I'm going to address one or two things. People were asking for the link to the website, which handles the domain architecture, as well as the GitHub repo for the code you were showing. And we will put those. Is it okay if we put those into the
absolutely
the attachment?
Absolutely.
Okay.
Yes.
All right, folks. So that'll be the the attachment. That'll be in the attachment, and that will be published later today on that Bright Talk channel at the URL, the content.pivotal.io URL. Thank you so much, Michael. Really appreciate your time, your attention, your presentation, and